Hello students, welcome to Long EduTech, and today is in the day 3 of the class 9 mathematics. Let us learn about the terminating and non-terminating decimal expansions, and also exercise 1.3 and 4 and all. Okay, so first of all, let us learn about terminating decimal expansions. Okay, so here terminating decimal expansions. Okay, so here those decimal expansions with terminate or we can say and after a finite step. Okay, after a finite step are called terminating decimal expansions. For example, let us see now 1 by 2. Okay, so if we divide 1 by 2, what do you see? 0.025 the 10, right? So in one case we can say those decimal expansion in which we get 0. Okay, that is the remainder become 0 when we divide. They are called as just simply the terminating decimal expansions. Okay, 1 by 2, that comes to 0.5, right? Or say 3 by 2, yeah, here also 3 divided by 2, 2 ones 2, what is say 1.010, right? Say 2 5 are 10, so it comes to 1.5, right? So such kind of the decimal expansions are called as terminating decimal expansions. Okay, so generally this will be helpful in class 10 also, you know. This is very important point. Okay, generally terminating decimal expansions are in the form of any number. Above it can be any number, that's why I write 1 by 2 to the power n, okay, and 5 to the power m. Okay, so that means that the denominator, okay, the denominator will be either in the form of 2 to the power n or 5 to the power m. That may be the multiply, or if 2 to the power n into any number is coming, then that will be wrong. For example, here 1 by 10. Okay, so here what you can say 1 by 5. 5 can be 2 into 5, right? To the power 1, 5 to the power 1, right? Then definitely this 1 by 10 will be definitely what? This will be a decimal expansions. Okay, we can easily understand that the given number will be decimal expansion or not by checking, or that means then I take LCM this one, 2 5 just 10, 2 into 5, right? So it comes 2 into 5. If it is in the form of this, then it can be a terminating decimal expansions. Okay, so you have we can check here 1 divided by 10, then 0.01, right? That is 10. That is how much we come? 0.1. Okay, so this is how, without doing the actual divisions, we can find out whether the given number is terminating or non-terminating. No problem, right? Okay, so this is a terminating decimal expansion, which will be in the form of 1 by 2 to the power n into 5 to the power m, where n and the m are what? Any power. Okay, any power, or you say integers, you can say, no problem if it is minus also. Okay, power or integers. Okay, fine. So this is all about the terminating decimal expansions. Okay, and now will comes to the non-terminating. For me, I can write from here, no problem. Okay, non-terminating decimal expansions. Okay, so this we can change it from these terminating decimal expansions. And how? Those decimal expansions, okay, which do not terminate or end after a finite step and remainder never become 0. We can write in this way. Okay, those decimal expansion which do not terminate or end after a finite step, okay, and remainder never become 0. Okay, remainder will never become 0. Okay, and such types of the expansions are called as non-terminatings. Okay, and the example, look here, 1/7. Okay, 1/7. Yeah, so let us see how. 1, if you keep on dividing, that we already done before, so 0.71 ja 7, right? 3 0 7 4 ja 28, and it comes how much? Say 2 7 2 ja 14, 6 already na 7 ja 56, 4, right? 7 5 ja 35, right? And 5 0 7 7 ja 49, again 1 remainder, then same things, it comes back again, right? So again 7 1 ja 7, so it will keep on continue. That is how much? 0.14285 I will tell you all this repeated number with a bar denote that is the non-terminating. Okay, and such type of the numbers are called as the non-terminating decimal expansion. Okay, so such examples are very important to know. Okay, yeah, and generally, you know, they are, I write that is non-terminating. Okay, they are in the, okay, they are not in the form of 1/2 to the power n 5 to the power m. Okay, that is the 1/2 to the power n or 5 to the power m. Like this, it will not be there. Okay, so this is all about non-terminating decimal expansions. Okay, clear? So we'll proceed to the exercise 1.3 now. Finish, right? Yeah. So these basic things we have to know. Just only the exercise calculations, it will not work. So theoretically we have to know, otherwise we will forget or will not be able to do properly. Okay, any questions? Okay, now let us go to the exercise 1.3. The question says that write the following in decimal form and say what kinds of decimal expansions, okay, is has. We have to make a decimal expansions. Okay, question number 1. Number 1, that is 36/100. Okay, if you understand about all this value nicely, then you can write directly here solution. At least you have to write once 100, that is how much will come? 0.36. Excuse me. And if you got confused about this one, directly divide, no problem. 100, right? Then here this is a 2 digit, this is 3 digits. Still then use the face problem and divide also. Okay, higher classes student also. So yes, I am explaining this for this. Okay, and point, this is 2 digits, 3 digits. That's why to make it 10, then we put a point here. Okay, so don't get confused. Before the point, we can write how many times of 0 you want. You can write, no problem. Okay, used to ask why 0 here. Okay, now comes to 3. Then 100 3s are 300. Okay, point already there. Then 106. That comes to 600. What do you see? The remainder is 0, right? So this is terminating decimal expansion. Okay, fine. Yeah. And second number, I think we should not waste time here because this is simple only. 1/11, right? For this one, you cannot do it short. We have to check. Okay, how you want to check, that's up to you. But they say that do the divisions. Okay, write the following in decimal form because we have to write in decimal form. So we have to divide only. Blindly we cannot say 0. Okay, this is 10, 11. This 10 is smaller, right? We cannot divide. Then we have to put another point. You keep in your mind, and one time if we put down the two numbers consecutively or successively, then we have to put 10 here. Okay, then how much? 11's 9s are 99, right? There. 10 minus 9, that is what? 1. Then 10 minus 1, 9, 9 minus 9, 0. We don't need to write here, right? 100 minus 99 to 1. Now, again, we already put point here. Can you divide? No. Again, we put another 0 here, then you have to put 1 0 up there. Again, we will go 99. So what do you think? This will finish? We will terminate? No. It will keep on continuing 090909. Right? So this comes to 0.0909. Okay. Or what you can write 0.09 bar. This bar denote this is non-terminating. Okay, the remainder is not 0. So this is non-terminating. Okay, decimal expansions. Okay, fine. Yeah, and student get confused here. I'll do up to this number 3. This number you can do, no problem. This is the 4 whole number, 1/8. Sometimes student get confused how to pronounce also this one, how to read. This is 4 whole number, 1/8. Okay, so this one 4 1/8 also no problem. That comes to what we used to do. This is the mixed fraction. We have to make it proper. So 4 into 8. 4 into 8. These two will multiply, and the above numerator will add plus 1. But 8 will be remain same. 4 8s are 32 plus 1/8. That is 32 plus 1 to 33/8. Okay, so now comes to 33/8. We have to divide, no problem. And how much we can go? 8 4s are 32, right? Remainder 1. Put point 0. 8 1s are 8 0, right? 2. 4 put 0. 8 2s are 16. 4, right? 0. 8 5 ja 40. That comes to how much? 4.125. We got a 0 here, remainder, right? So which is terminating. Right? Yeah. So this point we have to know. Okay, let us proceed to the next questions. You see homework. Okay, you can do the number 4 is 3 by 13. Number 5 is 2 by 11. And number 6 is 329 by 400. Okay, so this is the task you practice. Okay, and if you don't know, you can ask me in the comment section. Okay, now we'll proceed to the question number 2. Okay, fine? Yeah. Okay, question number 2. Question number 2 says that you know that 1 by 7 is equal to 0.142857 bar. Can you predict what the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without actually doing the long division? Okay, so how? Okay, and it says that study the remainder while finding the value of 1 by 7 carefully. Okay, so it's also given. So here given that 1 by 7 is equal to 0.142857 bar. That means that which is non-terminating. Okay, which is non-terminating decimal expansions. Okay, and the remainder never becomes 0, right? Which is non-terminating expansion. That's why, therefore, question says that to find out for 2 by 7 also. Okay, you know 2 by 7 can be written as how? 1 by 7 into 2. Any problem? No, not 2 1 2. 2 by 7 will come, right? That comes to 1 by 7. That means this one, 0.142857 into 2, right? Then here can comes to 7 2 ja 14, right? 5 2 ja 10 11, right? 5 2 ja 10 11 and 8 2 ja 16 17. Okay, 2 2 ja 4 plus 1 5, 4 2 ja 8, 2 1 ja 2 0, right? 2 0 0 na. So this will be this one, fine, which also will be a non-terminating decimal expansion, no problem, right? And we'll do some, not all, because it will be similar. Okay, this also how much we can write? 1 by 7 into 3, 3 1 3, right? 3 by 7, and that also comes to 0.142857 into 3. Here also 7 3 ja 21, right? And 5 2 ja 15, 16 17. Okay, 3 is ja 24 plus 1 25. Okay, 3 2 ja 6 7 8, 3 4 ja 12, 3 1 ja 3 plus 1 4.0, right? So this also. Okay, and so on. Okay, and so on. Okay, whatever the value we divide, it will get a non-terminating. Okay, we'll get non-terminating. Okay, decimal expansions. because the value of 1 by 7 is equal to 0.142857 is non-terminating decimal expansions. Okay, that's why we'll get all the values like this. Okay, fine. Yeah, so this is about the question number 2. Now we'll proceed to the question number 3. Okay, now we'll go to the question number 3. So question number 3 is that, what the question say, express the following in the form of p by q, where p and q are integers and q is not equal to 0. In the number 1, it is given that 0.6 bar. Okay, we have to show this, that is non-terminating by the bar, we understand, right? So in the form of p by q, we have to show this number. Okay, solutions here. What we have to do, first step, let 0.6 bar, right? Let x is equal to, let x is equal to 0.6 bar. That is how much we can write? 0.6666. How much you want, you can write. Okay, so this you take it as equation number 1. Okay, and you have to keep in mind after the point how many digits are repeated. So according to that one, we will multiply. Okay, here 1 digit is repeated. Okay, 1 digit is repeated. Okay, so if it is repeated 2, then you will multiply with 100. If repeated 1 digits, then 10. We will multiply both left hand side and right hand side by, or equation 1 by 100, or just say the 10. Okay, here the 1 digit is repeated, so we will multiply equation number 1 by 10. Okay, and we'll subtract. Okay, we'll subtract the equations, or equation number 1 from 2 also, no problem. Okay, so if you multiply this is x, right? X into 10, then x is equal to, don't get confused, 0.6 bar is already become 0.66, right? We will not take this one, we will take this one. Okay, so if you multiply, say 0.6666 into 10, how much will come? 66666 is how much we are. Okay, 1 2 3 4, 1 2 3 4. Nah, so like this point is to give. Nah, so 1 2 3 4, right? So the point is 4 numbers, so 1 2 3 4, like this. Okay, whatever. Okay, so just we will put a point here, no problem. Then comes to 6.666. How much you want to write? 6, no problem, up to you. This is question number 2. I said they will subtract, right? So this is question number 2. So therefore 10x. In subtraction, you can do 2 methods: left hand side, right hand side, or not. You can do little bit standard form, is equal to how? 6.6666. Okay, another one is just simply x is equal to 0. Point should be in the straight one lines, yeah, and we'll minus here. Denominator will change to minus. Okay, this will change to minus. Okay, I also or 1 also. Okay, all this 0 0 0 0. Nah, 6 minus 0 0, right? 6 minus 0 0, really? No, 6, right? A point here. And 10x minus 1, how much? That is 9x. Okay, that comes to, therefore 9x is equal to 6. Therefore x is equal to 6 by 9. But having the common factor, 3 to the 6, 3 to the 9. That comes to how much? 2 by 3. Okay, which is in the form of P by Q, right? So this one. Or in this subtraction, matter, okay, left hand side will subtract, like 10x minus, this is left hand side is x, right? X. Here also right hand side, okay, 6.6666 minus how much? 0.6666. okay, 10 minus x minus 1, so 1 is here, right? Then here it comes to 9x. Here also all these minus, then only 6 will left, right? 6. Therefore x is equal to 6 by 9. By cancelling here, 2 by 3, right? 3 to the 6, 3 to the 9. So which is in the form of P by Q. Yeah, this is the method that we have to apply in these calculations. Understand? Right. So we'll proceed to the next. Okay, second number also same thing, only one value is repeated. Okay, so I will leave this one and I will do the number 3.